Good morning, everyone. So my name is Alex Thornton. I'm a product specialist here at ThoughtWorks.
And my name is Paula. I'm a principal technologist at ThoughtWorks.
Yes, and for the last 6 or 7 months, Paul and I have been working together with a couple of people in the audience to help a financial services client break apart their large, kind of crufty, ineffective monolith into a series of more modern, flexible microservices. So when we asked the CTO what her goals were for the organization, one of the things that she wrote down on a piece of paper was this phrase. So right now, a lot of their data is handled in these big, kind of unwieldy overnight batch processes, and it's time for that to change. So Paula, when we talk about real-time and batch processes, what do we mean?
Well, as opposed to real time, let's talk about things that are not real time. For example, batch. And I do come from an era when even compiling was done through batch. If you don't know what that is, it is an active punch card. I could take a picture of you with it afterwards. But real time allows us, I collect punch card selfies. But real time processing allows us to react quickly to feedback, unlike batch where you might have to wait till the next day to determine if any of the payment processing failed. For example, you might be surprised to know that payment processing largely involves some kind of batch process at the end of the day. RTP is real-time payment processing, and it's only now becoming a reality around the world. For example, as recently as last year, November of last year, the United States Clearinghouse announced the capability to do real-time payments, meaning that when an e-transaction is processed, it's settled in real time, as opposed to the current kind of 2 to 3 day turnaround to actually settle the payment. When you manage things like cash flow, that can be very important to you. But Alex, as we see changes like this in the industry, we're dealing with clients who have systems that are maybe 5, 10, 15 years old. What does that mean to our software products and business processes in the real world?
Sure. So when you're talking about payments, the basic flow of a real-time payment versus a batch payment is actually kind of similar. Every single transaction goes through the process of authorizing, posting, settling the transaction, and then notifying both parties that everything is on the up and up. So if this is really just about getting your money a little bit faster, is it really worth all of the pain and suffering that your organization will have to go through on the way to enabling these capabilities? Absolutely. So take the financial services client that I'm talking about. They have a collections department where their agents will call their customers and say, hey, we need this money for reasons. And ideally, the customer will come to some sort of an agreement with the agent to make a payment. Now, in today's scenario, all that really happens at that point is the agent basically takes down the debit card information from the customer and hopes that it's good. They don't actually go back and get the money for another 3 or 4 days. And the problem is that a lot of things can happen in 3 or 4 days, especially where money is concerned. So for instance, what would oftentimes happen with the call center agents is that they would talk to someone on a Friday, come to some sort of agreement, but then by the time they went back to get the money on Tuesday, it wasn't necessarily there anymore. Besides providing a bad experience for the customer, besides providing a bad experience besides being financially unstable for the client, this also was a really bad experience for the agents themselves because they work on commission. So what would often happen is that, again, they would set up some sort of agreement with the customer, assume that they were going to make a little bit of money off of that as they were supposed to, and then not get it. That's not good. Enabling these new capabilities does require retraining your customers, retraining your employees, rebuilding your technology. That takes a good amount of product thinking and a product mindset, and you're going to hear a lot about that through the rest of the day. But first, we are going to start Friday off right with a big technical diagram. Paul, could you explain to the people what this all means?
The big complicated technical diagram? That's where I come in and you save me from it, right?
Let's see.
So let me break this down for you a bit. You see the big hairy technical diagram. There is a line at the bottom, and we actually use the terms above the line and below the line to talk about below the line being existing systems in a data center. existing business processes. So below the line is existing. Some people may say legacy. I just like to say reality or what's in production. Above the line, we have our new real-time payments product that we've worked with our client on in the rounded gray area. And then above that, you see two diamonds at the top that are external software as a service pieces or capabilities that we rely on to actually do the payment, Stripe or other industry payment processor, and then also identity management and API authorization. In our case, we're using Okta. We can talk about that more later. But let's do the GUI middle, which is the fun part, the payments product in the gray area. We have 6 blue rectangles there that are independent microservices deployed in a Kubernetes cluster. We rely on Kubernetes to orchestrate this bit. And we have this goal of only introducing complexity when it adds value. And you might say, well, gee, that looks really complicated. Microservices introduce complexity. You've broken things apart. And in the not too distant past, we might have just written one service to do this, exposed an API from it, taken the payment, had that service talk to the payment processor, flow the data in through facades to the back end. Why introduce complexity? Well, we actually get the benefit of isolating our dependencies, which is critical when you're dealing with legacy or reality integration. And also we isolate the dependencies or the capabilities of our software as a service solutions. And I'll illustrate a little bit with 2 of my favorite tech huddles. We don't have to do this in a big complex way with a lot of big complex technology. These are very simple services. The bit at the top lives to do one thing. It drinks requests from a queue, talks to the payment processor, puts the results in an outgoing queue. That's all it does. It's actually a very simple piece of code, and it does one thing, and it does it very well. So our infrastructure team had a little huddle with us around, how do we scale this thing? The default scaling in Kubernetes is CPU and memory, and we're pretty clearly not going to tax CPU and memory in that thing, so it might never really scale. It is single-threaded. The infrastructure folks said, why don't you just make that thing multi-threaded? And we were saying, why don't we just scale the pods based on the average length of time messages appear in the queue or have in the queue, which is a metric we can get from SQS. We're not using any fancy stuff, no Kinesis, no Kafka. It's just a simple queue. So it was really interesting to have that discussion with the people who build our infrastructure or Kubernetes for us, because if you've ever tried to write meaningful tests for multi-threaded code or ever had to debug a concurrency issue, you might be saying, can we please let our infrastructure do a bit more for us there? And you can also calculate the exact cost of scaling out pods in AWS versus it's a little more difficult to put an exact cost on complexity in code. There's no right answer, but it opens up all sorts of interesting and good design discussions that you should have about letting your infrastructure do more for you. And then on the back end, we had a discussion around, when do we get to buy our big API gateway that we've budgeted for this year? Because we now have 4 APIs and some facades, and I will say, why do you need an API gateway? We've covered API authorization through the use of our software as a service provider, Okta, which has a really nice capability to spin up multiple API gateways, which might be bounded by the product boundary or the truth boundary or the trust boundary. So that's all covered. And then when it comes to doing things like API throttling, we let our infrastructure do that for us. At the top, we talked about, and then at the bottom, where you really get the constraints, the legacy system or the reality system only being able to process so much, we can fixed scale the pods to control the flow through the back end. So we have yet to come up with a good reason for an API gateway. Maybe we will, but we'll only introduce complexity when we need to. And I see like so many eyes blazing at this point. Alex, can you save me and bring this back to the customer?
Let's see what we can do. So if you're like me and you have the benefit of just being able to stand next to Paula while she explains all these things and nod knowingly, it all sounds like it's very simple, but we understand that in reality these things are actually very complicated. And again, you may be debating whether or not it's actually worth the trouble. Now, in the case of our financial services client, we immediately saw the change and benefit once we started to enable these real-time capabilities. The call center agents were already steering customers towards products that had these real-time capabilities because it was a better experience for everyone, and also was, of course, more financially beneficial for their employers. We do have the technology, we do have the understanding. These things are very possible. So again, we understand that it will be difficult, but the move to real time is valuable. And with the proper product thinking, we can deliver real value in real time as we go. Thank you.
Thank you.